We are going to discuss about sum of subsets using backtracking method. Sum of subsets. Subset sum problem is to find subset of elements that are selected from a given set whose sum adds up to a given number k. We are considering the set contains no negative values. It is assumed that the input set is unique, that is, no duplicates are presented. Exhaustive search algorithm for subset sum. One way to find subsets that sum to k is to consider all possible subsets. A power set contains all those subsets generated from a given set. The size of such a power set is 2 raised to n. The backtracking method. A given problem has a set of constraints and may have an objective function. The solution must be feasible and it may optimize an objective function. We can represent the solution space for the problem using a tree diagram. The root of the tree represents zero choice. Nodes at depth 1 represent first choice. Nodes at depth 2 represent the second choice, etc. In this tree, a path from a root to a leaf represents a candidate solution. Sum of subset problem. Assume given set of 4 elements, same W of 1 up to W of 4. Tree diagrams can be used to design backtracking algorithms. The following tree diagram depicts approach of generating variable size tuple. In this tree, a node represents function call and a branch represents candidate element. The root node contains 4 children. In other words, root considers every element of the set as different branch. The next level subtrees correspond to the subsets that includes the parent node. The branches at each level represent tuple element to be considered. For example, if we are at level 1, tuple vector 1 can take any value of 4 branches generated. If we are at level 2 of leftmost node, tuple vector 2 can take any value of 3 branches generated, and so on. For example, the leftmost child of root generates all those subsets that include W1. Similarly, the second child of root generates all those subsets that includes W2 and excludes W1. As we go down along depth of tree, we add elements so far. And if the added sum is satisfying explicit constraints, we will continue to generate child nodes. Further, whenever the constraints are not met, we stop further generation of subtrees of that node and backtrack to previous node to explore the nodes not yet explored. In many scenarios, it saves considerable amount of processing time. The tree should trigger a clue to implement the backtracking algorithm. It prints all those subsets whose sum add up to given number. We need to explore the nodes along the breadth and depth of the tree. Generating nodes along breadth is controlled by loop and nodes along the depth are generated using recursion, that is post-order traversal.